Welcome everybody. My name is Phil Glennie. I am the Director of Sales and Marketing at Longterm Technology Services. We are a Siemens channel partner, and we're happy to be here today with you to talk about virtual commissioning for SMBs. This is a very important topic to us. We work with a lot of companies of all sizes. Maybe 10 years ago, virtual commissioning might have been the purview of larger tier ones OEMs, but recently we see this happening a lot more in the SMB space, and there are very specific approaches that help SMBs get value out of this software, compared to the OEMs or the tier ones, which have, these massive internal programming teams. And so, we want to just talk to you a little bit about the value of this software and why it has filtered down into the SMB space. My next slide here. So a little bit about our presenters today. In addition to myself, I'm very, very happy to be joined here today by Brian Shea, who's a portfolio development executive with Siemens Digital Industries Software. We're very happy to have Siemens co-hosting this event with us today. And in addition to myself, Tengwen Zhang and Kamal Han are my colleagues here with us today. These are, in addition to being our directors of R&D and commercialization and application engineer, they are expert Process Simulate users. So just to talk a little bit about that in-house engineering capacity that we have on the tool as well. And we're hoping to have quite a bit of time for Q&A, open up the software, let you ask the questions that you have about the UI, how it incorporates into your current workflow, that sort of thing. We're hoping for a lot of engagement today. A little bit about today's agenda. We're going to start off with Brian talking about the business landscape for digital twinning and virtual commissioning. From there, I will talk about today's solution that we are looking at for pursuing virtual commissioning, which is Tecnomatix Process Simulate from Siemens Digital Industries Software. From there, we're going to get more into the concepts of virtual commissioning and the workflows behind it. And then we're going to get into the live demo and Q&A so we can open up the software and you will be able to sort of ask those questions on the fly. Throughout this presentation, if you have any questions that you think of throughout the presentation, please don't hesitate to use the hand raise button. We're expecting quite a few people here today. So if you use the hand raise button up in the reactions tab of your Teams, we will get to your question in real time, or feel free to type your question into the chat box as this presentation unfolds. With that, I'm going to turn things over to Brian to talk a little bit about the business landscape for digital twinning and virtual commissioning. So over to you, Brian.
Okay. Hey, thanks, Philip. Hello, everyone. Thanks for joining today's webinar. My name is Brian Shea, and I work for Siemens. I support the Siemens software applications that are used by manufacturing planners. I've been doing this for over 10 years. I've worked, different industries like automotive, aerospace, electrical, medical, consumer products, and across U.S., Canada, and Mexico. And I'm located in the Detroit area. So our webinar today it's a joint presentation by Siemens and Siemens partner Longterm Technology. The subject is virtual commissioning for small and medium-sized businesses. And by virtual commissioning, I mean the commissioning of automation systems in like a virtual environment, like say on your laptop. So what you're doing is you're proving out and debugging your controls code before you even do the hardware build. Now, we wanted to do this webinar because we're seeing manufacturers increasingly specifying virtual commissioning in their request for proposal, their RFPs. And I suspect that there's some people in this session today that have already seen these requests that specify virtual commissioning. So we thought it would be a good idea to do a session to explain, well, what is virtual commissioning? What effort does it entail? And well, what's the business reasons behind this? Why are people doing it? Now, Longterm Technology has expertise in deploying and supporting the Siemens virtual commissioning solution on a kind of end-to-end basis. Longterm also has expertise with the other Siemens software applications. So I'm going to start out with a short explanation of the business landscape that is driving this direction. Then Philip and the Longterm team will take over from there. So let's go to the key trend slide here. Some of the key trends that are driving the demand for virtual commissioning of production systems, I'm sure you're familiar with some of these. The demands on automation builders are continually getting more complex, and the timelines for delivery and ramp up keep getting shorter. These are the trends that are the drivers of that situation. On the one hand, the far left there, consumers are looking for products that specifically meet their needs, which is driving many product variations. And the automation systems and the machinery needs to be smart enough and flexible enough to handle this larger product mix. But at the same time, automation builders need to be able to win bids against competitors from all over the world. And so how do we deal with these demands? And let's go to the next slide here. If you look at the different types of manufacturing processes, on the bottom left here, this is a fixed manual type of mass production. And it can do mass production, but it's difficult and expensive to scale it up. On the top left is flexible manual mass production. It utilizes some automation to assist the manual operation, but it's more flexible, but it's also difficult and expensive to make changes to that. On the bottom right is fixed automation systems, very prevalent today for mass production. It does the job, but it's also difficult and expensive to produce multiple products on the same line. So where things are moving is to this flexible, autonomous type of manufacturing. This is mass production that's flexible, but it's easier to accommodate changing product mixes. And that's the good news. The bad news is it requires more upfront engineering and planning. And this is where the digital twin of production systems is useful to speed up the design process and prove out the process before we actually implement it. So we're using the term digital twin here. Let's go to the digital twin, the next slide here. The digital twin, it allows you to build an automation system on your laptop before you do the physical build. And then you can do validation of the system, optimization of the system, before you do the physical build or even while you're doing the physical build. And this speeds up the process, gives you more flexibility, and lets you find issues before you start cutting steel. Let's go to the next one here. So this digital twin that we're talking about, this is the solution to dealing with the challenges that we're seeing for manufacturers today. The Siemens digital twin, it allows the different people involved in building the automation, the mechanical engineers, electrical, the controls group, robotics, to all work together on the same model. And it does so in like an integrated and secure kind of environment. We'll be talking about that today. Let's look at the next slide here. It talks about virtual commissioning and manufacturing simulation occurring at different levels. And when we talk about simulation, we can work at different levels in the process. So in this slide, the very bottom level, the one that says automation, this is simulation of hardware devices like the PLC and the HMI. And I suspect that some of you on the line here today may be familiar with Siemens solutions like TIA Portal and PLC Sim Advanced, which fall into that category. So Siemens offers simulation solutions at each one of these levels that we're showing here. But the one that we'll be addressing today is the second one from the top. It's called, what's it called here? Robotic Station and Line. This is a simulation of the automation systems. And it will be discussing virtual commissioning in the context of that level there. Now, before I hand it over to Long-Term Technology here, I'd like to make a few points, and I'll just kind of run down this list here one by one. So what's the situation in the marketplace? What's driving this? And what are we seeing today? And, number one there, a number of automotive OEMs and tier ones have standardized on the Siemens virtual commissioning digital twin tool. You can read some of the names there. And item two, we're starting to see that become an industry requirement when people put out their RFPs. You'll see some of these, you'll see a request that it requires the use of virtual commissioning. So this is why we want to have this discussion today, to let everybody know what are we talking about here. Number three, the Siemens virtual commissioning solution, it provides a single platform for simulation, for robot programming, and virtual commissioning of the system. So it's one tool that gives you those capabilities. Why are people doing it? Bullet number four, it's to mitigate risk. And it mitigates risk not just for, say, the OEM or the customer, but also for the people that are building the automation, because it gives you kind of a transparency across the whole process from beginning to end. It's not like the hardware shows up on the customer's floor and then we start commissioning it and validating at that point. Bullet number five, it creates more predictability for the project timeline because you're working in this virtual environment. You can identify issues like maybe crashes before they ever happen and eliminate those. The second from the last bullet there, I think we're living in this environment where there's long hardware delivery lead times, or there can be. And this leads to an issue in deploying automation systems. But the fact that we can build a digital twin on my laptop, validate it, prove it out, commission it on my laptop, it kind of mitigates the fact that maybe that hardware is going to be coming in at the last minute. And then finally, what the solution we're going to be showing today has this capability to provide collaboration between the different groups that are involved in building the automation. So these are like the mechanical engineers, the electrical, the controls, robotics, and by giving them all a single environment to work in and validate the system, this tends to shrink the overall project lead time. So that's kind of the landscape of what we're talking about, why people are doing it, and why we wanted to inform people of what it's all about and what it takes to do that. So with that, I'd like to hand it over to the long-term technology team to explain virtual commissioning in more detail.
Thank you very much, Brian. And so coming back now, my name is Phil Glennie with Long-Term Technology Services, and we're going to talk a little bit about Process Simulate prior to virtual commissioning, just to give you a little bit of a foundation on all of the things that it does that preps a simulation for virtual commissioning. A little bit about us first. So we are an end-to-end provider for this software, as Brian mentioned earlier. We have a lot of experience in CAD, CAM, PLM, simulation, FEA, virtual commissioning, digital twinning, and process design simulation. The end-to-end part of this I do want to emphasize because, Process Simulate is a very powerful solution with a lot of applications, and it benefits very heavily from live training and ongoing mentoring from experts, like the kind we have here with us today on our team. So I would say that if you are considering this software, I would say that, you should check that anyone providing it has that in-house expertise, and, they can answer the question, can you offer instructor-led user training on a guaranteed timeline? And can you offer that on-demand user mentoring on an ongoing basis after that? Basically, what I'm saying here is the provider of this software willing to take responsibility for your ability to use it? And that is something that we do with our in-house experts who are with us here today. And finally, we're a Siemens Smart Partner, technology partner. That means that we are certified experts on this software from Siemens, and technology partner means that we perform our own software development on top of the solution. So some three key value areas, especially in the SMB space for Process Simulate. are quick simulations and concept studies. This is referring to what you're looking at early in the sales cycle. So your cycle time studies, quick simulations. We've seen a lot of companies, especially SMBs, compete with much, much larger automation providers by creating these simulations up front and really giving the customers the confidence that they're already pretty far down the road in terms of the design of the process and the system. And we see this really helping companies win contracts in those early sales stages. From there, you get into your robot offline programming. Process Simulate is a platform where you can do robot OLL programming the same way that you would do with your vendor softwares, for your, Robot Studio, SimPro for KUKA, all of those softwares. You can do it for the most common robot brands, up to the 15 most common robot brands within Process Simulate, so one platform for doing all of that. And in so doing, you are prepping your simulation for virtual commissioning, so when you're driving that system using your real PLC or HMI. Typical challenges that people are addressing with Process Simulate are things like your fixture designs, your robot offline programming, you're validating your reach clearance with it, overall build quality, you're generating cycle times using the software's engine and algorithms. You're validating your safety, your controls through virtual commissioning, overall system layout, and any requirements that you have to meet, whether that be facility requirements or, as we're increasingly seeing, requirements from your customer. As Brian mentioned earlier, we're really starting to see a lot of these documents now coming out of the OEMs, and the OEMs are saying, for this project, you must use Process Simulate. There's even been situations where the people we were talking to thought that Process Simulate was actually referring to the phase of the project rather than calling out a very specific solution that they had to use. And in those cases, we have to point out, no, it's not just a project phase. Process Simulate refers to the tool itself. And with that, what you're doing is you're doing your process definition, your robotic programming, your automation controls, and your virtual commissioning. Now, some of this on the robot programming side, I'm going to move through this pretty quickly because this is the topic today is virtual commissioning. This is just more foundational for prepping a simulation for virtual commissioning. So here you're going to plan your production cell in your line in your digital twin at low risk, as Brian has mentioned, and you're going to detect and avoid interferences in advance. So what you're seeing on the screen here right now is an example of somebody performing their robot offline programming using Process Simulate. So here you have a KUKA robot with an end-of-arm tool that is doing a pick-and-place operation onto a conveyor with battery packs. And what this is going to demonstrate is the person using this software to detect a collision and then fix that in the robot program. So first, they're going to hit play and run this simulation. And we're going to see that when they do that, the end-of-arm tool is going to come down at a poor angle, and it's going to clip the edge of that battery, which you see highlighted here in red in the collision viewer, and down here in yellow is highlighted on the 3D as well. Once the user realizes that this issue is happening, they're going to use the software to get a proper approach angle here and jog that robot up and down on the axis to make sure that the approach is correct. Once they have the approach that they want, they will restore the gripper action, the grip closed, that they have now got the path they want. From there, first they will validate that the path is correct. Now they're happy with that. Now that the path is correct, they want to finish off this action by setting the motion parameter, the OLP command, by putting in the grip action there, adding that, rerunning it, and now the program is running appropriately. It's a pretty simple example, but this is just like to give you a sense of the UI of the software and how somebody is performing the robot offline programming within the software to generate that robot program that you will later virtually commission, and the fact that you can do this with any major brand of robot within Process Simulate all on a single platform. So there we were looking at changing the robot motion parameters and creating your OLP commands. Another really cool thing with Process Simulate is when you're doing your design reviews and your remote collaboration, this is something you can do with your own team. This is a single button you hit within Process Simulate to bring you into this view. You can do this design reviews with your team, or you can do design reviews with your customer if they want to get a sense of the scale of the system and really make it tangible for them in the design reviews as they are waiting for it to arrive and be set up, especially if you're waiting for the physical hardware. This can just help create a lot of peace of mind and can help them ask questions about the system and how you're going about designing it. And that allows for greater collaboration and evaluation of that system. Before I proceed, so I'm getting into virtual commissioning now. Any questions so far about what you've seen? Okay. Right, then I will bring us into the virtual commissioning segment. So this next diagram is to give you an idea of why virtual commissioning is becoming more common. So with a conventional design and engineering process for automation, you're typically seeing your planning stage, your requirements gathering, process planning, and your documentation. And then once it gets into design and engineering, you've got your mechanical team, your robotics team, and your electrical automation team working in a, I would call it a semi-staggered way. There's some overlap there between the groups, but in many cases, one group is waiting on something from the other group in order to proceed with their work. And then you move into the physical system commissioning, and that's where you are setting up the system itself, either on your own shop floor or at the customer's site for factory acceptance testing. If a problem is discovered at that stage, it is going to be discovered in the physical hardware. So you're going to get a collision, or you're going to spend a lot of time adjusting that system, moving things around, tinkering with it to get it the way you want. And then that kind of cycles you back into the planning and design and engineering stage to really remedy that problem. What's happening with virtual commissioning is that you still have the same requirements, process planning, documentation, but once you get into the engineering phase, because all of these things, the mechanical, the robotics, and the automation, because they are all validated and tested against within the exact same tool, the same virtual environment, that creates a lot more simultaneity in the work between those groups and a lot more collaboration, because people can basically dump their work into the Process Simulate software as soon as they really have anything, even a concept. And then from there, you're moving into your commissioning stage. And now that physical commissioning time is significantly compressed because it should be extremely turnkey by the time you get through your virtual commissioning. It should be one and done. It's all working the way you expected because you have validated that against the digital twin in the virtual setting. If you do catch a problem, it's going to be caught in the virtual world. And that will save you a lot of time and including money and possibly reputational risks if those problems were caught at the stage of factory acceptance testing. And the idea there is that a lot of time is saved, more financial return, and this is really being driven by the tier ones and the OEMs, especially, right? Because they need predictability over the timeline, and with hardware wait times and this and that, they need it to work when they turn it on the factory floor, and they cannot have a team in there setting up and tinkering with a system for much longer than they anticipated, which is why they need the peace of mind that comes with the virtual commissioning, which is why they are demanding it from their suppliers. Now, virtual commissioning solution overview. So the big thing to think about here is the fact that virtual commissioning is using your simulation that you have built in this program, but it is a signal-based simulation. So it is using your signals. And I'm going to give you an example of it here. In this case, you have two robots in addition to a pedestal, welding station, and a conveyor belt. So simple example, but just to illustrate the concept here. First, this person, as you can see there, is manually triggering the inputs. The spot welding gun is coming in there on the part, but there is not a program yet for that second robot. So the user here wants to create a program, wants to call a program that has already been created in the software for that second robot. So this gives you an idea of the UI that they are using to add that program. So they're adding in a new command. They're going into the path to execute. Out of the paths that they have already programmed using the same software, they're calling that path. They're calling the style and the process signal and the path to call. They're adding that in. And you can use these, you can customize all these commands. The other important thing is all of these commands are automatically converted into the syntax of whatever robot you were using. So these are good to go once you have generated these robot programs. And finally here they are adding the home position. And from there, now they've added that second robot's program to be called, the signals. So in this case, they want to send the part to the pedestal welding station as well. So spot welder coming in there. Now the second robot has the program to be called, is bringing the part over to the pedestal welding and then onto the conveyor to be taken away. So the next question I ask is, well, what if I want a variant? What if I want to skip the pedestal welding? Well, because of the way that they have inputted their paths to call, now they can very easily trigger the signals in order to skip that pedestal welding and bring that part directly to the conveyor. For this third example, we want to see how they address a problem that is caught in the simulation. So if in real life, service personnel left the gripper closed, is there a way to handle that with your signals and to safeguard against that, is the question they're asking here. So they are playing this simulation. They're manually activating those inputs. Spot welding comes in as always. The gripper comes in. That gripper is in the closed position, so it wasn't reset to the open state, and there's potential damage to that gripper, the robot, the fixture, all of it. This is not something you would want to catch on the real system. So this is a quick run through how the person is going to troubleshoot that. They want to reset the gripper to the open pose in the first location of the pounce operation to make sure that that is always the case. They're going to rerun this and test that updated program to make sure that they fixed the issue. Hitting the same inputs. Gripper opens. So now it is working correctly. And it is being taken to the pedestal welding station and onto the conveyor. So that just demonstrates another quick concept of how the user would catch an issue like that and troubleshoot it and remedy it within the software. And by doing that, you're reducing the overall time of your physical system commissioning, and you're improving the quality of that system, making sure that it is as turnkey as theoretically possible when it hits real physical commissioning. So you're testing your mechanical sequences, you're verifying your robot programs, and you're performing your overall system diagnostic testing on your controls logic. Now, there are two different types of virtual commissioning. One is called hardware in the loop, and one is called software in the loop. So for hardware in the loop basically just means you are taking an Ethernet cable and you are running your real device into your laptop that's running the simulation. So you're taking your PLC, you are running that directly into the computer, and you are driving it using the real hardware. You can see here your robotics, your equipment, your process, all of that is inside the hardware. Outside the hardware is your physical devices that you can run into that computer to drive the simulation. And that helps you avoid any of those unplanned delays during your system startup. And then the other example that you see here is software in the loop virtual commissioning. This is when, as Brian mentioned earlier, you are using hardware, software like TIA Portal, PLC Sim Advanced. You are emulating, you're simulating your hardware in this case. So this is valuable in cases where, let's say you need to be portable. You don't necessarily want to set up all of your real hardware to do your virtual commissioning. You just want to do it conveniently and emulate that hardware or your PLC, your HMI on your computer screen. Everything above here is the exact same. It's just more what you are using to drive that simulation, the real hardware versus emulated hardware. I want to quickly share the computer audio here to make sure. So in this next video, this is going to give you a quick walkthrough. This is Tungwon, who's with us here today, providing a quick walkthrough of connecting the software with the PLC, which will help give you a sense of the workflow that is associated with establishing that connection. And please let me know if you cannot hear the audio here when it starts.
So this is a short video to show you how you can do virtual commissioning with a virtual PLC from Siemens. On the left side, we have the PLC Siemens Advanced opened. Now we're going to create a virtual PLC called 5G test. Let's do that. So we have the 5G test, the PLC, running in a couple of seconds. So it's showing a yellow light, meaning there's no program in it. So on the right side, we have the TIA portal, which is a programming platform for the Siemens PLC. So we have control logics already created here. We're gonna download it to the virtual PLC we just created. So we can download it. So now the software is trying to download this, and it's completed very fast, and we can see the virtual PLC is showing a green light, which means the program is successfully loaded into this virtual PLC. Now we can go to Process Simulate. We have project here, and we're going to define the connection here in Process Simulate. So in Process Simulate, we can define a external connection, and we can choose from the menu as PLC Siemens Advanced. Now we can see the 5G test instance is already popped up there, and so we can just choose that, and we're going to map the signal using the address for the Siemens virtual controller. So now we can validate this test. It's just a process to see if it is actually successful. It shows it works well. Click OK. And yeah, and we just define the external connection to drive our simulation. The final step to do is we're gonna, on the right side of the process simulator, you can see there is a couple of signals. And we're gonna tell the software like which tags which controller you want this signal to be controlled. So since we have the 5G test already defined, so it's already popped up there. Now I think we can start our simulation. So in this simulation, we have a spot welding and we have a painting robot. So all the motions here are driven by external PLC. And we can switch out to the TIA portal and we can go online there. So that in this way, we can check the signal in real time. And you can, if you need, you can modify anything here and to debug your control logic. So that's it. If you go back to the process simulate, on the left-hand side, there is a simulation panel. That is really up to you. You can pick a couple of signals. You also monitor the signal status here. So sometimes this is a very handy feature that you can debug. Manually control some signals from here to test your robot cell. So yeah, so that's the process. It's a similar process applies to the Rockwell. Only difference is in Rockwell, we purely use tag name to map the signal.
Okay, and yes, as you saw from there, that was basically an example of how you are using the system to connect, process simulate the simulation to your emulated hardware. In this case, you're reducing the risk and you're accelerating all your product launches by validating your control signals before full commissioning. So quickly here, I want to go through a couple case studies of companies. These are more recent case studies of companies that we have worked with in achieving success with Process Simulate. The first is a Global Vehicle Systems based out of Tilbury, Ontario. So their challenge was that their controls engineers were waiting to access real production systems to start their debugging and validating their control logic, and they were spending more time tinkering on the shop floor during the commissioning stage, and they needed to speed up their factory acceptance testing. So we worked with them using virtual commissioning and Tecnomatix Process Simulate to increase their engineering transparency and their productivity and inspire customer confidence. So what they ended up doing there was saving 30% on real system commissioning time, double digit in their efficiency gains on the engineering, more business won, increased customer confidence. They're doing some really great things with internal design reviews on virtual commissioning, really checking everyone's work against the virtual system and doing design reviews with customers, also using virtual commissioning really to create that peace of mind for their customers, right? That they're seeing their future system being driven by the real control logic. We worked with Global Vehicle. We did formal training as well as on-demand mentoring and follow-up support to make sure that that they got what they needed to achieve these results. The next team that we were working with is at Ethos Automation. We just published a case study with them as well. They were losing time due to altering their robot programs after the shop floor setup, so they needed to validate and generate accurate robot programs more quickly, and they needed a competitive differentiator during the sales phase. This is what I was talking about earlier in the sense of they were also using those 3D concept studies and cycle time studies to help differentiate themselves in the sales stage, because if you're a smaller company up against a huge company and you might not be as well known, it goes a long way to show your customers something extremely tangible in terms of the system that you are going to provide them. And with that, Ethos was really able to work with us. We provided training, on-demand mentoring, got them all set up with it. And overall, they had a 25% reduction in their robot programming times, big increase in the accuracy of their cycle time estimates because they were using that engine within Process Simulate to generate those cycle times. More business won in the sales stage, more customer confidence. And as the co-founder and automation specialist, Calvin Kimura, says, with the addition of this to our toolbox, we've been able to supply our customers with a complete turnkey automation solution. Bringing this in-house, we were able to validate any automation project with a high level of accuracy. So there, I do see a question come in here. Okay. Okay, so I see here that there were some questions there about the volume level on the virtual commissioning video and setting up the connection with the PLC. So you did have the visual cues there. If there was anything you missed in the audio of that video, please don't hesitate to bring it up during the live demo and Q&A session, which is approximately right now. So with that, I will turn it over to my colleagues, Tungwon and Camel. So these are expert users with the software and part of our in-house engineering capabilities on it. And I will turn it over to you, Tungwon, to do this next phase, which is preparing the simulation for virtual commissioning. And anybody, please feel free to raise your hand throughout to ask any questions during this live demo.
Thank you, Phil. So anyone, if you have any questions, feel free to bring it up. And at the same time, what are we gonna show you is how we actually start from the very beginning to bring the model into Process Simulate and define the kinematics signals, and then how we actually gonna connect it to an external kind of virtual PLC. In this case, we are using Siemens virtual PLC, PLC Sim Advanced. So by that, I'm going to turn over to my colleague Camel to share his screen and show you the process.
Yeah. Hello, everyone. This is Camel Han from Longterm Tech, and I'm going to show you a short demo of the virtual commissioning. So firstly, I started with a blank project in Process Simulate. I just try to import the CAD files. So here is the CAD file. And I will try to firstly just create the JT file. So the next step will be importing, and this will be a positioner. Okay, try to import. And after you converted the CAD file, you will be able to insert it from your library. So you can always reuse your library components. And that's very convenient. Okay. So I have this positioner. I just try to modify its orientation and the location to make it stand at degree a little up here. Okay, so here we imported a positioner. I'm going to make it in the modeling scope. So here I'm going to define a couple of poses of the positioner, but before that we need to define the kinematics. So positioner will be tilting and rotating to place the parts. So here I start the kinematics editor. Let me first try to get the tilt. Okay, so this will be the tilt. I will create link, name it tilt. Okay. So before I define the other two, I can hide it for better selection. I will create another one, name plate. So this one contains these components. I can just drag these, not these ones. Plate. And just drag a rectangular to multi-select things. Okay. Hide it. And the rest of the components are base. Very simple and easy. So I have 3 groups of components. Now I'm going to define the kinematics. So between the base and tilt, we have a joint, which is a revolute joint, and I need to define the from and to for the joint. So this will be the axis that the joint will rotate around. So this joint has limits. I use constant limit. The higher limit is 90 and the lower limit is minus 90. I have the speed and acceleration as default. Okay, that. Show the plate and the tilt. So the next joint will be the tilt to the plate. The axis will be from bottom to top. And for this one, we have no limits. Just click OK. So we can now test our kinematics. So we have a tilt. We have the plate turning. Perfect. Okay. So now we have the positioner's kinematics defined. Now I'm going to define just the one pose for the demonstration. So we'll open the pose editor. It already has a home pose, which is the what it's like when you bring the model in. And now I'm going to create a new post named tilt. So for the tilting, I would say let's tilt for 90 degrees. 45 degrees is better. And for J2, say I would just let it turn 90 degrees. Okay, that. So now we can move between different poses and test the kinematics. And that looks great. Okay. Let me save the project. So I'll just save it in the PS demo. Let's name it demo. Okay, then we can go to the simulation mode, line simulation mode. So we have a line operation, and now I'm going to define a couple of the operations. So here we just do the device operation to change the pose of the positioner. I will say the device is the positioner, and the first one I will say to home. So this will change any of the current pose to home pose. I will define another one. The name will be to tilt. So this one will change any of the current pose to tilt. It's very simple. So we already have two signals that marks the end of the operation, but now we want to use the signal to control the beginning of the operation. So here I use operation signals, create device start signal. I highlighted the to home, so when I click it, the to home start is created. I will create another one to tilt. Okay, so I already have a PLC which has the signals defined, and here I just input the signals address. For the home, the address will be 1.3. For tilt, it will be 1.1. Now I'm going to define the PLC connection in Process Simulate. So actually, I already started the PLC Sim Advanced, which has a name of PLC1. So here I just try to validate if the PLC1 is connected, which is true. I have the signals, so the external connection. So I will tell the software that this signal is controlled by external PLC, which is from the PLC1 connection, which I defined in the options. Okay. Now we all set. Just run the simulation. Oh, actually, there is another step. I can send the two signals into the simulation panel, so I can always check the conditions, check the status of the signals when I control from outside. Okay, so we're all set, and let's run the simulation. So you can see the home start is already on because the PLC is on. Now let me start our HMI, which I created in the TI portal. And we just have one button to control the positioner's pose. So just start simulation. Okay, we have it here. So if I turn it on, you can see the tilt start is on and the pose is changed. Take it off, back to home. So you can, this one is a simulated PLC, but in real world, you can always, you may have a kind of external device to input the signals and get the output from the process simulate. So basically, this is a way to connect the signals and input and output of the process simulate with the external PLC or external controlling devices.
Yep.
Yeah, we can play it. Okay. So
Any-
here is the short demo, and if you have any questions, please feel free to ask.
Yeah. Any questions about what you've seen so far in terms of the workflows or anything regarding virtual commissioning, whether it's at the high level business or what you've seen here from a technical perspective? Any takers? I know one question that I hear a lot, Kim, on someone is the question of, like, so when you're dealing with like very, very large amounts of signals, like you had mentioned different PLCs like Siemens Rockwell, how do you, what are the best practices for bringing in lots of signals?
So I think Process Simulate can, well, you first you can yes, do the signal mapping. It's like if you have Excel sheet, right? You can easily get those from like TI portal or from kind of for Rockwell, it's Studio 5000, and you have that, and you can easily map it with Process Simulate. There are two ways of mapping. I would say for Siemens PLC, you either have the signal name, map the signal based on the name. So the system gonna look into the signal with the same name and connect and create the connection, and or by signal address. Either is input, output, it will map automatically. And for the Rockwell PLC and others, this can be done by mapping with the signal name. Yeah, so once you have that import, and everything going to be mapped automatically. So that's how we handle that large amount of signal mapping. Yeah.
Yep. And just a reminder, if you do have a question, please feel free, like you can unmute yourself or raise your hand using the hand raise function.
Or you can also type in the chat if you're not convenient to talk. Yeah.
Yep.
Quick question. This might be something that is just generally known, but I'm new to simulations. For bringing in the models of the different equipment that you guys are simulating, do you guys just have a general library, or is that something that as a user I'll have to create for the equipment that I have?
Yeah, I mean, you can basically, it's going to be from the very beginning, you have to bring all the components from your design. But you can, as Camel, I think he showed, you can save kind of a frequent used component, including the kinematics and all the kind of, signals, all the kind of detailed for future use. And basically you are building your own library while you are using some, and the library going to grow with you. Yeah, so that's how we handle this.
And the robots are provided from Siemens.
Oh yes, and the robots are provided. Siemens has a pretty large online library that contains almost all the brands of the robots, and it's being updated regularly. So you can, for the robot, you can easily download, and it comes with pretty much everything defined, kinematics and the drone limit, acceleration, all those parameters, and you can use for your simulation.
Yeah. In terms of the landscape here too, I would because of our experience, I would say there's some caution to be had on. There are solutions out there that offer like these pre-built libraries within them, but the trade-off with those is I would check, but often those ones that have those pre-built libraries, there's very little flexibility on what you can actually bring into them that are not in those pre-built libraries. So, if you need an end-of-arm tool for your robot, that company might say, well, no, we have to do that work on our end, and you're kind of at the mercy of their timeline. So I would just definitely check on that as well if anyone has encountered other solutions like this with pre-built libraries. I see we have some questions in the chat.
Yeah, I see that.
From Andrew and Adam. Yeah.
Yeah, Andrew, for your questions, maybe you can see more about the signal, but in general, if you are not using Siemens PLC, which you can see, you can set up the direct connection. You can also use the OPC UADA communication protocol, and you need a UPC server to basically set up the communication between Process Simulate and the whatever PLC, which supports the OPC kind of communication protocol. It's a pretty simple process. It's very similar to what we have shown you today. And also if you are using, a Rockwell PLC, I don't know, Camel, if you can bring the PLC setting menu here, perfect. So for Rockwell PLC, either it's a virtual one or a real one. If you can see, there is a menu we do have the processing. We do have the direct support for you to set up the direct connection. All you need to do is specify the IP address, like CPU and rack number, all the things, and then the signal gonna get mapped based on the name. So hopefully that answers your question, Andrew. And for Adam, if there a feature to bring in robot code, of course. I think Camel, you can also show that in Process Simulate. It's really a one platform for all the robots. You can directly upload your robot code, whether it's from the kind of FANUC, ABB, KUKA, right? So you can directly get them imported into this your project. Yeah, we don't have the robot here, but I guess Camel maybe.
Give me 1 sec to bring the robot to the library, and I can insert it.
Yeah, but anyway, that is a very typical operation. I mean, we do every day, I would say. Just if you have Robot Guide, Robot Studio already, you can easily just import all the code directly, and it will recognize all the things, and and in Process Simulate, and you can use those operations in your simulation and validate all the positions and etc. So can you run simulation while viewing in the virtual reality? Oh, of course, yes. So we can actually.
I think firstly, we can upload the program from external, say any type of ABB or KUKA robot code. That's the thing. Yeah.
So what do you do, like Camel? If you right-click the robot and you pick the robot controllers from from the
not exactly this one. Not exactly this one. Here.
Yes. So you see here from drop-down menu, if you can open that, perfect. So that is where you need to tell the software, right, what controller you are using and what version. And then after you define that, right, you can just directly upload the program.
Yeah.
Go ahead.
Sorry, I was going to say, Camel, if you could click on the drop-down list for controller, it does give a sense of all the ones that are in there. Just in case people were interested in seeing that. But if you can have a pretty good example there, right, of all the ones you would expect to see there, ABB, Denso, Epson, FANUC, any major brand you're gonna find. Yeah.
Yeah. And Adam, for your another question, the answer is yes. You can, of course, while you're running your simulation, you can be in the virtual world to see what's going on. Yeah. So, yeah, we probably
I actually have a video of that right here. I'll just quickly show it. But this is a person who's, if you can see my screen, they're running the virtual reality, right, with the actual hardware in the loop. This can actually be used. This is actually commonly used for training purposes, where you're training somebody using the real hardware and the virtual system prior to the delivery of the system. But you can see this is a person who's operating the system using their device and the virtual reality setup.
Yeah.
Yeah.
Yeah. And Camel, if you like, you can also show from your side in live mode for the simulation we just created. It's an easy one, but at least I think the concept is the same.
It is loading.
Yeah, it takes the time to loading. I don't know if we have enough time. We are already on top of the hour, so but feel free to ask if you have more questions. Yeah.
Yeah. The other thing I would mention here is I'm actually going to quickly launch a quick poll here as well. If you can all see it, this is just a quick poll on if you would like to answer whether your company plans on acquiring this type of software or whether or not you already have it, just to provide some information for follow-up. But yeah, so I did want to emphasize again the importance of having that end-to-end support when you're using this type of software. So basically people who can guarantee you a timeline on the training and guarantee you that on-demand mentoring when your user needs to contact somebody to talk about this kind of software, because it is very powerful, but it really benefits from, formal training and mentoring. The other thing I was going to say is, sorry, back to you, Tungwan and Campbell. Has it loaded?
Exactly. Yeah, it's seems like. Let me cancel this. Try to reload again.
Yeah.
Yep.
And we are at the top of the hour, so as we are wrapping things up here, I also wanted to ask Brian for any closing thoughts as well. Thank you very much for being with us here today, Brian.
Yes, thanks, Philip. I just want to thank everybody for joining us today. The main point we wanted to get across is that this virtual commissioning capability is been standardized on by a number of companies, and that's starting to appear in requests for proposals. So we wanted to make that point, let people know what is available, give them a feel for how it works. And if you'd like to find out more information, get more details, give Philip and the Long-Term Technology team a call.
Yeah. And for contact information and follow-up, you can respond to any of the emails that came out in the last couple of days about reminders. Those came from my account, or you can use the contact information that you see on the screen here. Also, if you would like a recording of this webinar to bring back to your teams after the fact, please don't hesitate to let me know, and I will share the recording back with you.